Alright, in example 3 part B, they give us another set of criteria and they want us to sketch a curve. So let's take a look at how we can translate this information into some sign charts and then go from the sign charts to a curve sketch. Alright, so let's start with f prime of x. They tell me f prime of x is positive on the interval from negative infinity to negative 2 and from 0 to 3. So let's first of all lay in those critical values. So we have negative 2, 0, and 3. So they tell me f prime of x is positive from negative infinity to negative 2. So we'll put a plus here. And we will also put a plus between 0 and 3. And they tell me it's negative between negative 2 and 0. And it's negative on the interval from 3 to infinity. So as far as my original function is concerned, it's increasing, decreasing, increasing, and decreasing. So that takes care of the first two. Now, they also give me some information about f prime down here in E. So let me see if I can make use of that. It says that f prime of negative 2 and f prime of 3 is equal to 0. That means the slope is 0 there. That means that these are local extrema. And since the original function is changing from increasing to decreasing, that means that at negative 2 we're going to have a relative maxima. And since f prime of 3 is equal to 0 at 3, we're going from increasing to decreasing. That'll be another relative maximum. Now they also tell me that f prime of 0 does not exist. So in other words, the function is not differentiable at that point. So that's something we're going to have to satisfy. There's some things that we can do to make that happen. Let's take a look at our second derivative. F double prime of x is less than 0 or negative from negative infinity to 0 and again from 0 to 5. So let's put our critical values on our number line. Okay, so they say that f double prime is negative from negative infinity to 0. So that's going to be a minus sign. And they tell me it's also negative from 5 to infinity, so that'll be a minus sign over here. Sorry, that should be positive. 5 to infinity is greater than. 0 to 5, it's also negative. And also, remember that since f prime of x does not exist, f double prime of x definitely does not exist. What does this mean for my function? So since it's the second derivative, it's talking about concavity. So concave down, concave up. So the function is differentiable everywhere except x equals 0. And certainly that would explain why f double prime does, f prime of 0 does not exist. They also give me another hint. They tell me that at 5, 1, I have a point of inflection. And so P-O-I at 5, 1. And again, we could have figured that out for ourselves because the concavity changes here from concave down to concave up. So 5 has to be a point of inflection. But I would have no way without a function of finding out the corresponding y value, so they did help me out by giving me that point. Notice there's no point of inflection at 0. Biconcavity doesn't change. Well, let's start with a point of inflection. Let's plot that point 5, 1. And I'm going to label that as my point of inflection. So to the left of that, my function is concave down. So it must be coming from higher up. And this is going to be concave up. I'm going to go ahead and sketch a concave up portion of my function. So concave down. And that's coming from probably a maximum, and that'll be located at 3. So 1, 2, 3. So this will be a relative max, and this function is concave down. And again, to the right of 3, we're decreasing. Function's decreasing. Between 0 and 3, the function is increasing. So I don't have a corresponding y value for 0, so I'm just going to make one up. But I am concave down between 0 and 5. concave down between 0 and 5. Between 0 and 3, the function is increasing, and between 3 and infinity, it's decreasing. All right, let's take a look at the left side. So they tell me that I have a max at -2. My function is increasing from the left, decreasing to the right, and it is concave down. So concave down from -infinity to 0, concave down from 0 to 5, concave up from 5 to infinity. Concavity checks, increasing from -infinity to 2, decreasing from 2 to 0, increasing from 0 to 3, decreasing from 3 to infinity. We have a max at -2, a max at 3. F prime of x does not exist. We have a cusp here. We're good. We've got it.